Hi, welcome back to the channel. Thanks for tuning in again today. CDI units, either dual or single. So we either have a no start issue with the single CDI, or we have only one ignition is operating, the other one isn't doing anything. How do we find out what's wrong? It could be the stator, expensive and difficult to get off the engine. It could be the ignition pickup coil, not so expensive, but still a lot of work. Or it could be an ignition coil, much easier to change. But we can't just guess at what's wrong with it, because triagnostics are not the way to go. We need to test to find out where the problem is. So I'm going to show you how I test these with some very simple tools to determine where the problem is. So what tools do I use for this? Well, you can use an inexpensive DVOM, digital volt ohm meter. You probably have one of these, and hopefully you know how to use it. I'll go over the settings on this when we get to that point. Or you could use a auto ranging meter, much nicer. I have several of these. The things are great. And you need a couple of jumper wires. That's it. Now you can do all the testing that you need to figure out, does the stator work? Does the trigger work? Where's the problem? So we'll do a quick review here of the settings that we're going to be using. This is your basic meter, and we're looking for volts. It's off right now. Read the instructions for your meter, of course. But when we're looking where there's a V here for volts, and we see there's a straight line with some dots under it, that signifies DC volts. So this would be in a 20 volt range. So if you were checking the battery in your car, this is what you would use. But we're not using DC volts, plus minus. We're using AC volts today for this test. So here's another V over here. And here's our AC sign right here. And it's a 200 scale. So we'll select the 200 scale in AC volts. So this is the setting that you will use on the whole testing on this meter. So now we'll go to the auto range meter, and now both volts are beside each other. Of course, there's the line with the dot. So this is DC. Don't want that. AC. We want this one here with the sine wave signal image right there. So we'll select there, and there we are. So this one is measuring in AC volts, and of course here's our sine wave right here, so it confirms on the screen. You can see this will read in millivolts. That's what the M is for, so millivolts, so less than a volt. We don't have any indication on here of what, when we're in DC or AC at all. So we have to know for sure with this meter, basic meter, to tell us that we're in the right scale. So 200 volt scale AC. Being that this engine is equipped with electric start, this is really going to be a big aid to us. It's way more difficult to try and do it with a rope. Although you will get outputs with a rope, this is a much steadier reading. So it works better if you've got electric start. So we're going to go ahead and we're going to test the stator first. So how do we do that? Well, we have to access the wire connectors for it. We're going to do this one first because it's the easiest. It's right here. I'm going to cut this clamp from there, and this is going to have the green and white wire, and it's coming out of, a little difficult to see, it's coming from the crankcase, where it goes into the crankcase and goes to the stator. So let's just wiggle this and disconnect it, wiggle and pull. And the wires look good. They're not, the covering coating is still good, so that's excellent. So we're going to take a reading right off of this connector right here. So we're going to connect our jumper wires to our test lead, because it's easier, because then it's clamped on, and the engine might jiggle around a bit when we crank it. And because it's AC, we can hook up either wire. The fact that this is blue doesn't matter. It could have black, white, any colors you want on these test leads. Okay, so now we're connected, and I've looked down to ensure that this end is not touching the other end or shorting out on the workbench or anything. So there we go. We're hooked up there. And here's the meter. Let me move this so we can see the meter. And again, we're in volts AC. It's going to auto range. Let's move this down a bit more. There we go. Okay, now let's crank the engine over. The spark plugs are still in. All the plug wires are hooked up, everything. So let's crank it over and see, do we get an output from there? So we saw on there 95 volts. So 95 volts at cranking speed is more than sufficient output from that half of the stator. So this powers this coil right here. So we know that this coil on the mag end is getting power going to it from the stator. So that's a good check. Now we got to move over and we need to check the power supply from the stator for the PTO coil. So I have to reposition everything to do that. So before I move, I'm just going to switch this out for the basic meter. I'm holding on to it because it doesn't really have a good kickstand. And get the light on it. Okay, let's crank it over and see what we get. So 90 volts with that meter. So we'll access this coil, the PTO coil. The plugs, connectors are right here. We'll just gently bring them out. We don't want to grab them with pliers and pinch them or anything. And so here's our green and white wire again. So we're going to get in here and pull it and give it a little twist, and it's removed. So here's the connector we want to access. So this one right here is the one that we want that comes from the stator. And again, I'm looking at the wire at the top and it doesn't look degraded at all. So let's get our alligator clips on here, our jumper wires. And I got that one there, that one in there. So we're connected. And I'm switched back to the auto range meter. And I'll just hold it right in here and crank it. And we'll see what we get from this side. There we go. And 90, I'll call it 90. And we'll switch meters again to the really basic one. There's common and volts. And there we are right here. Oops, there. And here we go. I'm going to crank again. 89. Okay, so I marked that down. That test is complete. Now let's check the next item. So we'll just carry on. I want to check the trigger for this coil. So let me disconnect these leads, get them out of the way. And the trigger wire, you can see in there it's blue with a little bit of yellow on it, and it's red on the coil. So we'll gently pull and give it a bit of a twist, and there we go. Now this is the part that comes, this is the connector that comes from the trigger right, here's the trigger, here is that trigger. So this is what we're checking, and there's the wire right there. So this, we want to check output on that. So connections now, well, how do we do that now? Look, we only have one wire instead of two wires, right? We don't have two wires, green and white, we just have one. Remember, we're working in AC volts, so we can hook one into that lead, and the other one, we just need to hook it onto the crankcase somewhere where we know we have a good connection. So I see one down here, and I'm just going to connect it. Or actually, you know what, for demonstration purposes, I'm just going to connect it onto the coil bracket. Okay, so this is bolted all the way through, so we'll use that for a ground. Now, let's get, I've already got this meter hooked up, so we're going to continue on and use the basic meter. Let's see what we get for voltage output on this one. So 4 we got on there. This is where this meter is a little more difficult to read because it's in 200 scale. So let me switch this over to the other meter, auto range meter, get this connected, and let's come back with the auto range meter and let's try this again. Here we go. Here's the auto range meter. So 354 millivolts. And the other one read 0.4. So that would be their, you know, it's reading as 0.4 of a volt. So now we're back at the mag end coil. And we want to find the wire that connects to the red one out of that harness. You see, this one's easy to identify because it just goes right through the bracket and down here. So here it is, and again, it's blue. Looks like it's had some kind of repair right there. And so we disconnect that. We'll just wiggle it around to make it a little more accessible. Okay, so there we go. So that's our trigger for the mag end coil. And again, I'm going to connect in with one, and the other lead is just going to go on to the crankcase. And I'm still connected to the digital, auto ranging one. So let's crank this and find out what we get on this one for output. 3.5, I would call that, or 3.5 millivolts, 355 millivolts. Did I read that right? Let me check it again. Yes, 350 millivolts. Let's change back to the basic one. It's probably just going to say 0.4, a little under a half a volt. So that's common goes there. All right, so what do we have on this one? Here's our basic meter. We're still connected. And here we go. Crank it again. 0.3, so a little bit less. Let's review the output that we have so far. So this is our stator output. This is using the auto range meter. On the mag side, we had 95 volts AC. And on the PTO side, we had 90 volts AC. It did jump to 92, but okay, I put 90 down. With the basic meter, we had 90 volts AC and 89 volts AC. They're pretty equal, these two meters at that point. So is it a pass or a fail? Absolutely a pass on both of those. So there's nothing wrong with the stator output, and there's no reason that does not supplying enough to make this engine start and run. It'll go up as it goes faster, but RPM increases. But so we don't have any issue with the stator at all. So then move on to the trigger. So trigger wise, we're using the auto range meter. And this is where the auto range meter really shines as far as I'm concerned for this, because we're in lower voltage. So we're at 354 millivolts AC, and that was on the mag, and this one was on the PTO, and 355 millivolts AC. Okay, but see where this really drops off. When we're using the basic meter, it says 0.4 volts, I guess because it's a little over 3.5 volts, so it will switch to there. And no, I don't know how it changed, but anyway, over here it just says 0.3. So you don't have the accuracy to check the triggers very well with the standard basic meter. So if you're going to go buy a meter, get an auto range one that'll go in millivolts. It's way better. Now, this is a perfect output. There's nothing wrong with either one of those. So what do we got so far? Stator is good, triggers are good. Now next, this is an interesting concept that they've figured out quite well, and it's a real safety device that's built into these coils. So we know that we have a minimum cranking RPM of about 250 or 300. So we'll just say 300. So the engine has to run, it has to be cranked at least 300 RPM to make spark. Well, that's interesting. Why? Well, the input circuit, which is the trigger, I should say, I should have put trigger circuit. So the trigger input circuit requires a minimum of 260 millivolts to actually make it through the resistors that are in the circuitry in the coil, because I've taken it apart and looked at it. And it drops it down where it actually only has 78 millivolts arriving at the gate to trigger the gate of the SCR to release the charge in the capacitor to make the spark happen. So what I know is that I need at least 260, or I could even round it up and say I need at least 300 millivolts input for enough voltage to make it to the SCR to make a spark. So we'll just say, we'll round this up to say 300. And what did we have over here? Here's our input, 354, 355. So we had more than enough to trigger the, to close the gate on the SCR on the circuit board to, for the SCR to conduct to ground and release the charge in the capacitor to make the coil fire the spark plug. So at this point, if it still has no spark, there's one other thing that you can do before you go, okay, the stator's good, the triggers are good, it must be the coil? Not necessarily. Okay, let me move the camera again. So now that we've proved out the stator and we've proved out the trigger, and this right here, for example, is the ignition that does not work, what else can we do? Well, we know that the green and white are the power in, so we'll look at the wires there. They look fine. We'll check the red wire. It looks fine. And what is this yellow and black for? So let me just unwrap this down here. And this is another very valid test that's pretty simple to do. So here I've separated this wire out. And what this one is, this wire is the P-lead, or the one that is grounded through the ignition switch or the key switch to stop the engine, to turn the engine off. So what would happen if there was a problem in the airframe and the wire was rubbed somewhere grounding? It would ground this and shut this off when you don't want it to. So your switch is in the run position, the key is in the run position, but this wire could potentially be messed up on the airframe. So let's disconnect it from the airframe and support it somewhere where it's not going to get caught in anything. Let's start the engine up and find out, does this coil all of a sudden work now? Well, you just found the problem, and it wasn't anything in the ignition here. It was the airframe. The switch is broken inside, the wire is grounded out somewhere, whatever. And that's a pretty simple test. So just disconnect this P-lead, or the shutoff wire, from the airplane and see what happens. So you had it running with the P-lead off. It didn't make any difference. This coil right here still has no output. Well, that was an easy test to do. You just disconnected a wire. So it's looking like, what are you going to need? A new coil. So you're going to need another coil. The only exception, and it's pretty rare, is if the harness is moving around all the time, the inside of the plastic coating on the wires, the wire can break inside. So it's worth having a look at that first. If you don't see anything wrong there, then once in a while, it's very rare, these need a new coil. So while we're still talking ignition systems here, Here's the spark plug cap. I don't know if you knew it or not, but it has a resistor in it. It's very important that you check it from time to time. How do we check it? We slide the boot back along the wire like that, and it's actually screwed on. So it doesn't pull off, it's screwed on. So you'll see there's a little hole in the wire when you take it off. You should nip a little bit off the end to give it a fresh surface to screw into. And when you look inside here, there's actually a screw in there. So let me set up the meter and I'll show you how we test these. I'll be using the auto range meter for this just because I like it better. The other one will work just as well to do this. So we're not going to be using our voltage anymore. We have to change to resistance, which is this little horseshoe, the little omega sign, whatever you'd like to call it. This is for resistance. So we'll select up to resistance, and it's switched to milliohms already because it's looking for a reading. So when I touch it together and I have no resistance, then it says 0.5. So that's what's in the leads. So if you're doing something super accurate for electronics, you need to realize what your meter actually, like when it says 0.6, it's really 0. But anyway, enough said about that. We're not doing electronics right now. We're doing these. So inside, when you look deep inside of here where the cap goes on the spark plug, if it's all black down inside there, probably no good anyway. And the same at this end. We want to see the screw in this end, and it looks pretty clean, and it's pretty good in that side. I can see in there, you can't. So I'm going to push the tip in until I get to the brass that's down at the bottom where it actually connects to the spark plug. Then I'm going to come in this end and get a good contact on the screw. And the reading I get is 5,000. That's what the dot's for, 5,000, because it's in, up here it's in K. So 1,000, so 5,467 ohms. These should be 5,000. Typically they're maybe a little bit less. But when you know it's no good, what result you're going to get. If you get 4,800, it's still fine. They don't have to be exactly 5,000, just like this one's a little higher. It's not a big deal. But if you put it in and you get the open circuit, then it's broken inside. And although it's screwed into the spark plug wire and it's hooked onto the spark plug, there's really no electrical connection. So the spark has to jump the gap inside of here where the resistor is broken. And that's a problem. So you should always get a reading here. If you do the test and you put it in and you get just, it says OL, then there's nothing. Then that means that this is no good. And that's the doorbell. So now that we know that this spark plug cap is good, we need to reinstall it. We're not going to put it back in the same hole that it was in. So what we want to do is we just want to cut off about maybe a 1/4 inch. So just nip off a 1/4 inch. It gives it a nice fresh end to screw into. If we took the boot off, I use white grease on all of this, so I put a little daub of lithium grease on it. Well, it's a big daub, but anyway. And then slide the boot over, scrape off all my extra. And I always put some in here. Then we want to, this will self-center because the wire is the same size as the hole. Give it a little push to get it started. And to make sure it's on all the way, I always kind of just like keep my pinch it right there and I don't move because I want to see that this is screwing on. And it is screwing on. And it's getting tighter now. And I screw them on until they don't screw on anymore. There we go. And then slide your boot ahead. And away you go. So this should be, when you put spark plugs in, you should be checking these every single time. So, 50 hours, 25 hours if you're on leaded fuel, 50 hours if you're on unleaded fuel. Make sure that you check these. Generally, by the time they're 100 hours, they're usually not that great anymore, 150 for sure. So these are not a last forever spark plug cap. Now I've fitted the same engine with a recoil starter. So let's find out what we have to do if we're using a recoil start. This is when the basic meter I don't think will be of any value whatsoever, and you're going to need the better meter. And I'll explain that shortly. So because when we're pulling the rope, it's going to be a little bit difficult to try and get a glimpse at the screen because it won't be there long because the engine's not spinning at a constant speed like electric start. So there's a couple of things that will be a little bit different in the setup this time. We're still going to use volts AC, but then on this particular meter, we're going to use the manual range selection, and I'll be using the max selection so that it'll actually hold the reading on the screen. So whatever way your particular meter works, read the instructions and do that. But these functions here are just not available on the basic meter. So this is, if you got a recoil start, then you're really going to have to get one of these kind of meters that has all these functions on it. Now I'd like to make my connections for the trigger wire. So remember, that is the blue with the yellow stripe on it. So I can put either wire. Remember, it's AC, so it doesn't matter. So one connection here, and the other lead I'm going to put right on the crankcase. Now I'm going to zoom into the meter, and so you can see what I'm going to do that's different this time. So I'm still going to select, so I've made my connections. I'm going to select volts AC, same as we did before. Now the range I don't have to adjust because it's already on millivolts, and that's what I want because I'm expecting millivolts from the trigger. Then I want to know what, because when I pull the rope, the RPM is going to go from 0 up and back down to 0 again. I want to find out what the maximum is, that output is. So I'll just push the maximum button, and you see right there it went to max. So now for the trigger, so I'm at max, I'm on millivolts, I'm on AC scale. So let's pull the rope and see what we get for output. Okay. That's once, at 310. See if I can pull a little faster. 323. So now I'm going to record that, and I'll move on next to the stator. So just for simplicity, I'm going to set this to off again and disconnect from the trigger, and here is our stator charge coil output. Remember, green and white. So either wire goes on there, doesn't matter which one it is. There's no polarity, it's AC. Now let's zoom in on the meter again. And okay, so I'm going to switch it on. So again, I selected volts AC. Now I'm in millivolts, and it's still in the auto scale. I don't want millivolts, I want whole volts. So I'm going to push the range button, and it's going to move the decimal point. And volts, I want to move it over so that I can read in hundreds if it was going to. So if it was going to be 100, it would be 100. So this is the scale that I want right here. So 1 volts. Now I want to push the max button. So I selected max, AC volts, and I'm in the volts with the decimal point as far to the right as it'll go. So let's pull the rope and see what we got. Oh. All right, I must be getting tired. Anyway, so 73 was the most that I got. So you see how that worked. Every time you pull it, it retains the reading. And if I pull it faster the next time, then it retains the highest reading because it's on max. So we're going to record that 73 volts. Now I realize the engine looks different now because I've had it all apart. I'm reassembling it now, which is why everything, it has no coil plate, and of course the spark plugs are out. I was trying this with the spark plugs in it to make it more realistic, but the bench kept moving. So I did it with the spark plugs out, but it doesn't matter. If you want to do it with the plugs out, plugs in, depends on how good you can pull the rope. So we've recorded our results. Now let's put them on the whiteboard here. And from the green and white wire, we had 73 volts AC. And from our trigger wire, which is the blue wire with the little yellow tracers on it, 323 millivolts AC. So what did we learn from before is I mentioned that we need at least 260 millivolts input here. So here's our 260 millivolts AC minimum to trigger the coil. Did we meet our minimum voltage even at 300, which I said we could round it up to 300? Before I mentioned that, let's round it to 300 millivolts AC. Did we have at least 300? Absolutely. We had 23 extra, 23 more. So there's more than enough charge from the trigger coil to close the gate on the SCR that's inside of the coil assembly, which then goes to ground, and the capacitor dumps its charge, and it makes a spark, induces a spark in the coil in the secondary, and we get spark at the spark plugs. So our trigger coil is fine. Our 73 volts AC from our charge coil in the stator, more than enough to charge the capacitor. So with this, if it's making it should make a spark at each plug, and we're good. We just went through the whole system. Now, if you should get a good voltage, you've just proved the charge coil is fine. If you get more than 260 millivolts, then you just proved that the input from the trigger coil is fine. Where can we get a difference in the trigger coil? There is a variable in the output voltage from the trigger coil if the gap is not correct. So this gap that's in between this metal bar that comes by as the flywheel turns, there's a magnet and a coil of wire in the trigger coil that makes it actually induces a voltage into the trigger coil. So the gap in here should be 0.020 inches. So that's what this gap should be in here. So if the gap was wider, say 30 thousandths of an inch, then we're not going to have the same effect when this bar is exciting or triggering the trigger coil, because it can't induce the same voltage because it's got a wider gap in here. So it's critical that the gap in there is correct. And as I said, 20 thousandths of an inch is the correct gap. Then we can expect it. So if you have a weak output from the trigger coil, you need to check the gap. Maybe the gap is wrong. Maybe it moved somehow. It wasn't put in the right place to begin with, and maybe you can't pull the rope as fast as you did before. So I hope you enjoyed this presentation on how I check the ignition system so I can troubleshoot them right away, quickly, efficiently. So is there a problem with the stator? A problem with the trigger? Or, as we just went over, the gap on the trigger coil? Or do we have a wire issue? Do we have an airframe issue where the airplane is turning the ignition off when you don't want it turned off? Or is there an issue with an actual coil? Lets you figure out much more efficiently than just changing parts to try and understand why it's only got one ignition or it doesn't start because it's single ignition. And I can't say enough about a good meter. A basic meter, that's okay. But if you're going to do troubleshooting and you need the functions that are available on this meter, then you're just not going to get the results, at least with the pull rope recoil, as you would using a basic meter. I didn't even try it because I know it doesn't work. So anyway, thanks for the time you spent with me today. Appreciate it. Like, share, subscribe, hit the like button, send me a comment. All right, have a good one. Bye now.